Alright, this is going to be really basic and down and dirty. I have a truss here. Assume a pin on the left, a roller on the right. 4 coming down. By law of the lever rule, 3 will be up on the right, 1 will be up on the left. I want to solve for the forces in these members right here. 1, 2, 3 members. So of course we will use the field command. Use the wipeout command, and you need to decide what your methods are going to be. But if you look at this, basically if we want to solve for the force in this member here, I'm going to do a break and then extend through, since that would extend. Screw that. If I want to solve for the forces in right there, I want to cut through this. I'm going to use something like a wipe out, and I'm just going to go ahead and even probably use my ortho a little bit every now and then and go all the way around those, because those are no longer there. Of course, if we want to solve for this member here, the place that's going to take the 2 of them out is going to be right there. So I'm going to do a circle from the end point of that one there, and that's going to be my new rotation point. Now realize the force here coming out and the force there are unimportant because they come through that. All we're going to need to do is solve for that force right there. So we're going to try to do a line from the end point there, and then we're going to hurt on F8. We're going to make it 1 in that one direction, and we should probably put that on something like a reaction layer, internal reaction. Right now we're going to put it on an object. Here's what I want to show you, however. We can now actually go ahead and move cross everything. And again, if you have to be this, make sure everything's thawed and on. We're going to grab it from there. We're going to move it to 0, 0, 0. Now if we were using the field command, everything would update. But if not, we can just go ahead and list this one here. If you notice there, we have a radial vector there. We see that that one is there at delta x, delta y. That's your force. Here's your radial cross product. Once again, this one here. And so you know that basically this has to react to that. We know, of course, it can be based on orthogonal distance, but we do have basically a cross product here of, if we look across here, it's going to be a positive, the way that's shown. I think it'll be a positive 1.17, and this one here is farther away, and it would have a cross product equal to something else. This one, of course, is the one we've already calculated. This is the one that's going to change, so it will have an equal and opposite moment there. So, of course, if you were doing this, you can change the coordinate system, but if you're using the field command, you need to actually move your whole system. I want to now point out that if you knew this value here, you're left with effectively 2 unknowns. That means you could use a concurrent force in your calculator. So that sense, the other thing, of course, you could do would be to change now to take these 2 out of the equation. Instead, put a circle at the end point there. And once again, perhaps move or just change your UCS, this case, UCS to the center of that. And now your unknown force would be something that looked like this, with the direction of that and a length of 1. Of course, these 2 would come out, and you have force times orthogonal distance equals force times orthogonal distance. So if we list that once again, or put our mouse over the top of that, kind of hard, don't know why it's not doing it. There it is. And then the same thing here. Of course, this only works, of course, if you have solved for the reactions. Once again, shifting around the coordinate system works pretty slick. So those of you, once you know how to solve for reactions, realize you should be able to do this both in CAD, but even more importantly, just learn to add a constant x and a constant y to all your radial vectors, and things should work out pretty smooth. Thanks for listening.